What's new in Java 23 and why should you care about it? Find out from the best leaders and experts who are closely involved in creating these new Java features and the ones who will help you to use them. In today's episode of JEP Explained, we'll cover JEP 469, which is about the vector API. So, what about it? This feature is about an API for vector computations that would perform better than the scalar computations. Are you wondering what kind of applications would benefit from this API? Is this API platform agnostic? And how does it relate to Project Valhalla? And probably you'll have many more questions. So let's find out. Get ready to discover what you have been missing all these years. Hi everyone, I'm your host Mala Gupta from JetBrains, and to talk about JEP 469 today, we have with us Zoran Sevarac, founder and CEO of DeepNets, a leader in deep learning AI, co-author of JSR 381, Java champion, conference speaker, and a lot of other accolades which I had to leave out because we could not kind of have a single episode of talking about just the accolades. Hey Zoran, it's a pleasure to have you with us today.
Hi, Mala. Thank you for having me.
A pleasure to be learning from you today.
Yes.
So, before you start talking about the details of this API, I would like to understand from you what are scalar and vector computations and what kind of applications are we targeting with these computations? Are we talking about computation intensive applications like the AI applications or other applications as well?
Well, yes. First of all, scalar operations are just like regular operations, like with two numbers, like a scalars. When we have a single number and you want to add two numbers, we are talking about scalar operations. Or you want to multiply those numbers or divide or whatever. When we have arrays, when we have vectors, which consist of several values, several numbers, then we have typically in Java we have arrays. Then we are talking about vector operations. And important thing is that modern CPUs have support for so-called vectorized operations and so-called vector registers, which means that you can fit entire array or part of array into that vector register and perform some operation on multiple values all at once. So you don't operate on a single value, single numbers, but you perform the same operation on the entire chunk of values in array. So if you have, for example, these so-called AVX registers with 512 bits, and you want to perform operation on floating point numbers, then you can perform operation on 60 values all at once, compared to just adding a single value when you're performing scalar operations. And it happens in a single CPU cycle. So theoretically, you can have if performance improvement up to 16 times. It's usually slower than that, but we'll talk about that later.
And what kind of applications are we targeting with these computations? So, are we talking about computation intensive applications like the AI application training the models, or does it also apply to regular applications?
Well, it applies to a application. Probably they will benefit most of it, and also all kind of applications that have numerical computations that have lots of calculation over the some numerical data, um, and for training AI models, but also for inferencing. Maybe it is more important for inferencing because they can significantly speed up, especially from Java. All those models running on CPUs, they are being trained on GPUs, but running inference on CPUs, but they are all using vector operations, even for the libraries written in C and C++, other low-level languages. So also for kind of end-user applications, for business application developers also, but they are not primarily intended to be used on objects. They are primarily targeting crunching numbers when you have lots of numeric data and data structures which are represented as arrays, as vectors or tensors, basically multidimensional array. So if you can represent your problem in that form as arrays or multidimensional arrays, then or use libraries that use that kind of data structures, then you can benefit from the performance improvements. Otherwise, with plain objects, they're the same, pretty much useless.
So, Zoran, I heard a lot of terms which we do not usually hear when we talk about application development, or I would say for a regular average Java developer. So, what do you think is the target audience of the feature? Are we looking at developers working for on their applications, or more importantly, are there any prerequisites for working with this feature in terms of knowing about topics or in terms of hardware too?
Mhm. Well, when it comes to type of applications, it looks to me, but maybe I'm a bit subjective. It's mainly targeting library developers, and this kind of API developers, and not so much application developers. But maybe I'm just not aware of it. If you can transform a collection of objects into a data structure which is based on arrays and perform fast computation and then turn them back into objects, then it would make sense. So, but it just depends on how many objects and how much time do you need to perform that operation, conversion from objects to arrays and then back to objects. Also, if objects contain that kind of data structures which are based on arrays or vectors, then it would make sense. The simple answer, as always, it depends on the use case, and that's why the incubation process is ongoing. The authors of this vector API want to see how will people use it, for what kind of application it will use it, and what challenges will they face, and what will happen with it. So it perfectly makes sense. Otherwise, I think it is a very good idea, which is available in other languages too.
I guess I'm guilty of asking multiple questions in one question. So
Mhm.
there's one part that you missed. It's about, do
Mhm.
we have any prerequisites regarding in terms of hardware that we would require to better have better results from using Vector API?
Yes, prerequisites are basically, to my knowledge, are fulfilled if you have like a modern CPU which supports vectorized operations, and you have these vector registers. Then you have these requirements, prerequisites. You fulfill the requirements, but there are also many tiny details and catches. As I'm not an expert on this, but from what I read on the blogs over internet, Intel CPUs have this AVX 512 register, which can store vector values, vectors up to 512 bits. And AMD also have something similar. I'm not sure about the other CPUs. Probably they have, because this vectorization has been around for years, from like 90s. And the thing is, uh, there are there are some challenges. What if a vector cannot fit into register? If it is too big, then there are techniques that the vector API provides a way to solve. And there is one specific feature of vector API called masking, to know which part of the vector has been calculated and which is not. So sometimes the if the CPU don't support masking, then you have to perform the computations that are left using the for loops. So that's one thing to see how it will work out, and it's a pretty not so very nice solution. And basically, it will require rewriting the existing code, and it could be error prone.
So this API talks about making working much faster than the scalar computations. So what apart from the slow speed, what are the other pain points of using scalar computations? And are we looking at suggesting moving away from scalar computations completely?
Well, I think that we cannot move from scalar computation completely because there are many use cases where it makes more sense to use them. If you don't have a big arrays, and if you don't have performance improvement with vector API, then we should stick to scale operation, but not because from some benchmarks that also saw, there are operations which are not improved using vector API, because using vector API also comes with a cost. First, you have to convert an array to this vector, which is by saying to the JVM, you should use this for the vectorized computation, and then you can, after performing computation, if it is a large enough array, then it makes sense, and if it fits well into the register, and then you can you have to convert that vector into array to send values back, and that's also one thing that requires some time. So if for a specific calculation is faster using vector app, which have to be benchmarked, there is no general solution answer to that, then it makes sense. So scalar computations are here to stay. They will stay forever, but in some cases where it makes sense, it can be beneficial to use these vector operations. So I can show an example. There are lots of blogs on this topic. So basically, this is like an example showing how to add two arrays. Um, so like a for loop, we have two input arrays, we have result array, and we have for loop arrays adding each consequent element of the array to the result. So this is basically this adding using for loops. And this is how you do it using a vector API. Okay, so we have two arrays, and then we convert these arrays using this static from array method, and we convert it to int vector. So we create int vectors from these arrays, and then we perform add operation. So this one here, this operation, this addition, should be performed by this vectorized operation if the CPU has this vector register. And then at the end, it converts back this vector to array. So this is the main flow. So one thing that might look confusing is what's this species thing here, right? So this is array, and this is species. It usually you have this species preferred. So this is a setting which says how many values from vector you can fit into the register, because sometimes you have registers with 256 bits, and sometimes you have registers with 512 bits. So you don't know on which CPU you are going to be executed. And if you have 256, then you can fit in like 8 integers, right? Each one having 32 bits. And if you have 512, then you can fit 16 integers. So it's a kind of low level. You have to be aware of those low level things, but it's a quite good abstraction. Of course, there is always, uncertainty what will happen on a specific CPU. And if the vector does not fit, there is this way to loop through the array, to go through the entire array. If the entire array does not fit the register, if it has like more than 16 values, like 100 values, then it takes chunks of 16 values and put it here. And then you see this method from array. It says which is offset, from which index it is taking. And there is this loop bound method from species, which is again platform specific. So when the JVM is compiled for the specific CPU, this species provides us this information, how much, what is the size of the array that can fit into the register. And again, this is a mask. So this is a mask which we need to know which values have been already calculated. So if it does not fit at all entirely, then at the end, it performs this final calculation for the things that are not calculated. So as you can see, it is very promising. It is very handy, but there are still details that have to be worked out. Sometimes you, as Java developers, we are not used to think about what's going on a hardware level in the CPU, in the register, and there is many things. Also, there is a caching, and I don't know. I haven't found some information when multi-threading comes into the play, how it will work out. So I assume that each core has its own vector register. So if that's the case, then it shouldn't be a problem. But again, the scheduling of threads, you don't know how it is going to. So there might be in multi-threaded applications a lot of waiting for this. It can turn out to be a bottleneck. So that's why I assume that's why it is incubating. There are many things that to see how people will react, how it will be used in practice, and so on. But it is being used already. I saw this some vector databases which are pretty popular for this using generative AI are already implemented using this feature. And myself, I'm also investigating at the moment for implementing parts of my deep learning library using this vector API, and I expect a lot of improvements. But again, it's not a small effort, and same, it will always be a lot slower than GPU, because GPU, this vector API is only for the CPUs. That's what I get from some of the conferences when there are authors presenting, only for using vectorized operations on CPU, and GPU is completely out of scope. And GPUs will perform this on a much larger scale.
Wow, that was a lot to sink in. And
Yes.
the looping part that you showed, is it something like the way we have paging with memory management? Is it similar to that concept?
Yes, yes, yes. So if you have like a more elements, then you take and you have register of 512 bits, you take 16 elements, put them in a register, perform. Then you take next 16 elements, put them in the register and perform. And next 16 and so on. So you don't take a value by value, but take a chunks, a parts of specific size of array and move it into the register and perform the operation. And because of using this vector abstraction, it can be int vector, it can be float vector, it can be double vector, depends on the size of the element type. It depends how many elements get fit into the vector register.
Right. And you just mentioned that this would work better with CPU and not GPUs. And what if a system has GPU? So this
Yeah.
vector API is not going to
It's
work with
not
that.
it's not for the GPUs at all. It doesn't
Okay.
cover the use case at all. It's only intended to be used for the vectorized operations on CPU. On CPUs we support them. And by the way, I looked. If you look at the source code of these vectorized operations, all of them, this addition and other operations are annotated with the force inline. So the hotspot compiler should replace all this with like a native CPU instructions and avoid method calls with adding and everything else. So it should be a lot of
Mhm.
performance improved.
And since you mentioned hotspot, I have a question related to that. So it was mentioned that hotspot's auto-vectorization algorithm. So how does it work, and how can developers use it? Is it like they can force it, or is it something that happens implicitly when vector API is used?
Well, basically, when vector API, to my understanding, I'm not an expert in it, but my understanding is that you're enforcing, you're explicitly telling to the hotspot, you can use auto-vectorization for this part of code. At this point, it is left up to the Hotspot compiler to recognize which code can be vectorized, and it always depends. Will it recognize it? And there are many situations maybe it won't be recognized. But if with vector API you explicitly saying to the Hotspot compiler, this code can be vectorized in this way, and you're saying explicitly what is the size of the array, how many can fit into the vector register, and so on.
So, Zoran, you would also help. I would want you to help us understand what you mean by single instruction, multiple data in terms of vector API.
Well, the simplest way to think of it is that you have like two arrays and you want to apply the same operation to all elements of these two arrays. So, for example, you want to add them or you want to multiply them. So you have a single instruction, for example, addition or multiplication, and you want to apply on a multiple of values, a set of values, on all values of two arrays. So that's multiple data. So it happens as a single CPU instruction, and it happens on a multiple values. That's it.
Okay. The other when we were discussing about these points, so you had additional information on this topic, or no? So some other topic, I guess.
Well, basically, no. This is the essence of the vector API. This concept is also been around for a number of years, for like on a CPU level, on a lower level, but it was the question how Java can benefit from it. So the first approach was to use auto-vectorization to see when something repeats multiple times, okay, over the same data. So you have typically arrays, so you have same operation on multiple data, so that if the data can fit into the register, then it can be vectorized. But with this vector API, you can automate, explicitly say how to do it. And the same principle is performed on GPUs. You move the entire data on GPU, it performs the same operation all at once. So that is a kind of parallelization, but you don't use cores, you don't use thread, you do not parallelizing execution of operation. You are doing the same operation, but you are doing on multiple chunks of data.
So, Zoran, what are the common vector operations?
Well, as I mentioned, some of them vector addition, subtraction, multiplication, also matrix operations like dot product and all of these arithmetic operations, and of course tensor operations, which come down to vector and matrix operations. So basically, all the operations which are heavily used in machine learning algorithms are the operations that can be considered to be vector operations. And basically all of the linear algebra, solving equations, different numerical models based on linear algebra. Well, I mean, basically that would be like more than 50% of computing algorithms are being performed with vectors.
So, are there any other examples that you would like to show us? You mentioned that you would be referring to some uh, uh, code or code samples that you have bookmarked. Do you want to show them now?
Yes, yes, yes. I would really recommend reading this blog post from Baldung. I share the links with you at the end. So this is how you basically hello world example, and this is how to perform with this multiplication. So again, floating vector, again, and multiplication, and reduction operations, calculating averaging of value, using how to use masks, and some like challenges with it. Also, there is a good presentation, like a benchmarking, which is a bit old. Actually, this one is not that old. This is 2023, I guess not with the latest release. Like a very good explanation, theoretical, and some benchmarks with code, because these are different operations. You'll find it. Sometimes there are claims you can get the increase of 100 times using vector API. You know, it can be with this case with the fuse multiplication and addition. This is ax plus y, which is basically calculating a linear function. You have like a single operation for linear function. But if you do have that case, then it is possible, but it won't be always the case. So you should understand your algorithms and understand how it can be parallelized and how to benefit from vectorized. So it's not just something you just import and call a method. You have to understand your algorithm, and you have to understand how API can be used. So these are different kind of benchmarks, and performed on the JDK 11, and it always depends on the CPU that is being used. So sometimes there is speed up factors up to 11 times. Sometimes in other benchmarks there is no significant difference of the vector height, because JVM performs several optimization on itself. So if it manages to apply auto-vectorization, then you don't need a vector API. So it is interesting to see, and I think it would be very good to have this kind of benchmarking, some kind of official benchmarking. No, not to wait for the community to write this and that, but benchmarking from the development team to see specific instruction guides, how to use, how can we benefit, not to leave here's the technology, now do the research for us. I think that will help adopt, that will help people to understand how can they benefit. And there's an entire blog post again that is for Java 18 about vector API, that we get a free speed up. And there is explanation also that for this hello world simple adding up, there is no improvement in speed. As you can see, it is the same actually, adding two arrays and then applying to the third. But for some use cases, they can be like initial improvement in speed. So I really recommend this benchmarking using JMH, and I think this is what you need to do in order to evaluate if you can benefit from vector API. So this is fuse, multiply, and add. This is so efficiently using it, it can provide like a lot of performance improvements.
Thank you so much for sharing those links. And everyone's watching will share the links to all these documents that Zoran shared with us in the description of the video, so you can access all of them. So on that, Zoran, any closing thoughts from you on this API?
Well, I must say that I'm pretty excited about this, despite all the unknown details at the moment. But I'm pretty excited, and I have very high expectations. I hope it will stop incubating and become like a part of the JMEM very soon. It's been a while. It has been incubating, and I must say that from time to time I've checked it, and it looks much better now. It's more readable. It's more like something that the Java developers are expecting and are open to use. But yeah, it's not a small effort to rewrite something and use vector API. And before getting into it, I think everyone wants to make sure that it will pay off, So like more benchmarks and like some information about when and it can be beneficial would be very helpful.
Yes, the JEP also mentions that once Valhalla is out in preview, this API would move from incubation to to being a preview feature. So let's hope that that happens soon. And as you mentioned, you have used this API in your library as well, and it has shown promising results. So I guess a lot of other developers are using it too, and all of us
Yeah.
developers get to use it sooner than later.
Yeah, I honestly hope it will be available before Project Valhalla because we don't know. This looks like a close to being ready. I'm not sure, but for Valhalla it might take time. It makes sense because all these primitive types that will support that will come from Valhalla. Basically, this is working with the primitive types, arrays of primitive types, primarily for that, but we do have primitive types now. I'm not sure how Valhalla will happen, why it is, but yeah, it makes sense.
Yes, as you said, this is not a small effort. So it's a big, a lot of effort is going into both the Vector API and the Valhalla project. And fingers crossed, let's hope it is out in the preview soon.
Yeah, because I think
Yes.
it will be big push for the development of AI application. It is something that
Mhm.
Java is missing, and if it want to keep up the step with the modern hardware development, it is something that it
Mhm.
must have. Yeah.
Yeah, that makes sense. So on that note, thank you so much. It was a pleasure to learn from you, but we're not done yet because we are done with the serious stuff, but now we have two fun sections for you. The first one coming up is the tongue twister. So I would display a statement on your screen, and you have to read it at your regular reading speed. You cannot slow down while reading that. The
Hmm.
idea is to uh, have a difficult sequence of words so that you trip while you read it. I hope so. And your time
Hmm.
starts now.
Hmm. AI analyzes angular arrays, aligning aggressive algorithms with vector API, while Swift Scalar scrambles synchronized scalar sequences.
Oh my God. I think I'm being too nice and creating simpler tongue twisters for the speakers.
Yeah,
But full points to you.
yeah.
You aced it.
Probably difficult for someone who's not familiar with the terminology, but this is what I read all the time. Stuff like
So
this.
So full points to you on that section. So the next section is about reacting to a couple of statements, three to be precise. I would display three statements to you one by one, and you have to react to those statements as if you are using an emoji. The only difference is you cannot type the emoji and you have to enact it. So if you want to say thumbs up or you like it, you have to do like this or something like that. So you have to act the emoji. So this is the first statement. Java 23 is about abilities.
Oh. Give me, you want it.
That is one of the most amazing expressions that I had from the speakers. Thank you so much. So we
Thank
all are
you.
excited about the release
Yeah.
of Java 23. This is the next one. AI is ready to be used in critical applications. Okay. So you're saying it is ready to be used in critical applications.
It depends what kind of AI, If we're
Mhm.
talking about predictive AI, it is definitely ready. So for generative AI, we do have
Mhm.
something more to learn, and to see how to handle this and how to
Mhm.
evaluate the mistakes. And it is ready to be used, but also for the predictive AI, we do have to be aware of the possible error and
Mhm.
acceptable error threshold. So it can be estimated and tested.
Mhm.
As long as AI is ready, but I'm not sure that those who should use AI are ready to be using it. They have
Ah,
to know how to use it the right way. That's yeah.
that's an interesting perspective. So probably the answer would be one thumbs up and one thumbs down.
Yes, depends as usual,
Depends. Yes,
like an
it,
expert answer. It depends.
it
So
depends. Yes,
yeah, if you want more, you have to pay me some money to tell you on what.
absolutely. So,
Yeah.
so the last statement is, given all the complications that you have in your current work, you'd rather prefer to start farming to earn a living.
Definitely not. Definitely
No,
not.
no.
No, no, no,
you,
no.
you, so where you have to enact, you have to say thumbs up, thumbs down. Okay, that's much better. Oh my God, this is much better. This is amazing. Okay, so on that note, it was such fun talking with you, Zoran, and a pleasure to learn from you. Thank you so much for
Thank
your
you.
time, and thank you for talking with us today.
Thank you very much, Gupta, for having me and for great questions, and also to JetBrains. I think you have this great podcasts.
Thank you so much. And everyone's watching, stay tuned because we would have more interviews coming in the series, which is JEP Explained. And until then, bye bye.
Bye bye, everyone.